Hello, my name is Rich Howard, and this project that we're going to use the CNC machine for is creating custom ceiling tiles for a client. So we're going to call this version 1. So version 2, tighter corners, bigger end mill, and moving it over on the workpiece so I can get a spring clamp down here. I could just run a screw through it, but spring clamps are fast, they're easy, they're faster to remove if a tool is headed in their direction that I didn't anticipate, and whatnot. Now I'm going to do a file save as. I'm going to call it version 2, V2. Oops. File save as V2.75 mil. We'll get rid of that. We're going to call it that. Okay, so we could take all of this, could do an offset. And I don't have a lot of experience offsetting this because I would normally just redraw it further away. But we're going to, yeah, I didn't like how that worked. Move selected objects, relative. Yeah, so we're going to go from this datum point. Our XY is 3/16 if you recall. Well, let's now take that and just simply make it 3. And it moved it. Now, actually, that's not what I want. That's what I want. So I can get enough moved over here. Now, of course, all that's wrong. Very likely a way to adjust all of that, but that's how I would move all that over. Now, what's interesting is let's apply, let's close. Okay, let's just try this. I want to test my idea that we can physically move this and retain all the same tool paths. All right, moving it over that far is not a problem. All I'm going to do is change my workpiece because my sheet, if you recall, is actually 97 in the X. Tool will cut through. Yeah. All right, so this is not all even. So basically a 1/2 inch. That's not going to work. 1/2 inch gap. When we do that profile cut, it's going to cut into the next piece. So I think I put this at 3 inch, if I recall. Let's check. Yeah, 3. So let's make our sheet. Let's just roughly call these 24 inch. 6 feet. We can leave 1 inch between them. 72, 73, 74, 77, and then 80. So let's change this to 80. Okay. Yep. Now, let's select all of these, and let's just move them out of the way. Let's pull a guideline right on that one, and let's give ourselves a relative guideline 1 inch over. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's close. Let's turn off the guideline. Well, no, can't do that. Well, let's turn them off for a moment. Selected. Let's turn them back on. Now let's move them to where our profile lines up with that. Beautiful. Now, let's do, these guidelines are screwed up, so let's just move them. And whether it's a hard 1 inch or not, it doesn't really matter. I just don't want it less because that bit diameter is 3/4. Yep, relative 1 inch, close. Now I'm going to grab all of that. I'm just going to kick it over. Beautiful. Okay, so we've got a guideline there. That's good. Well, yeah. So let's create a new guideline. Relative 1. Create. There it is. Let's grab all of our vectors. Let's copy them. And now let's just move them up. That was 1 inch. And that leaves us right where we wanted to be. So now we should have all of these tool paths ready to roll. Okay, so we are not ready to roll. So all I did apparently was copy the vectors over. I didn't copy the tool pathing over. And admittedly, I don't know that it works that way. I assumed that it does. Clearly it doesn't. So not the end of the world, because what we're going to do is we mimicked our same tool path, but we have to add our 1/8 inch tool path as well. And I think what we need to have is the existing vectors need to be a profile cut with the 1/8 inch. And then create 3 more vectors kicked in a 1/16 of an inch in towards the center in each X and Y direction, and then create a pocketing tool path for the 3/4 inch bit. The fact that the tool paths existed, you can take vectors and copy them like I just did, but apparently we didn't pick up the properties of the tool paths. That will be a study for the future. So what I'm going to do is I'm going to delete all these tool paths. This is saved as version 2. So again, as Chris Burns would say, this is a drawing exercise. Delete all visible. Okay. It's a drawing exercise. So what I'm going to do is I'm going to get rid of all of these vectors. Yeah, our guidelines are all off. It would just be easier to delete all of the guidelines and start over. Delete all guides. Okay. So that means that we're going to get rid of this as well. And that'll be okay. I'm not worried about that. So let's start with guidelines for our modified position and design. So 3 inch, because we want our profile to be 3 inch over. That will give me, I'm going to walk to the tool and actually make sure that will give me enough room. going to put the dust skirt on, and then I'm going to move the tool to 3, 3, M2, 3, comma 3. And then I'm going to go MZ 0.5. Okay, now I'm going to inspect. So 3, actually it won't be 3, 3. It'll be 3, 1. That's just not going to work. It's not going to work because it's still too close. M2, I'm really starting at M2 3, comma 0.1875 is really where I'm going to be. And when I move the tool to that position, I'm good. My bristle is going to run over the top of the spring clamp, but I'm okay with that because my cutting tool is never going to be even close. So I'm fine with that. So now we're going to need AutoCAD back up again because I don't necessarily recall all of our dimensions. So we'll need a guide at 11/16 and then 3/8 and then 3/8. All right. So 11/16 relative 0.6875. Create new guide. Close. Relative to 0.375. Okay. Close. Now this, if you recall, it's 23 and 13/16. 8125. Create new guide. Close. Now relative negative 0.6875. Create. Close. Relative to negative 0.375. Create. Close. Bring one down here to 3/16. So all I did was I dragged the guideline down. New position. 0.1875. Apply. Doesn't matter where you drag it to. I mean, unless you can drag it right to where you need it to be, but there you go. So now I need to do the same thing that I did earlier. Relative 1, 23.8125. Create. Close. Relative 1.6875. Create. Close. Relative 2.375. Create. Close. Relative 1, negative 0.6875. Create. Close. Relative 2, negative 375. Close. Now these are going to be my profile paths. And I'm going to experiment with throwing all these once I get the tooling done to a layer, which I'm yet to do, but I want to be able to separate my profiling tool paths from my pocketing tool paths.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video.
Let's move on to the rest of the video. I'm just checking the math on all this with my measuring tool. So let's make these as tool paths. So let's close. Let's select the first vector. Wait a minute. Yeah, that'd be fine. Set. This is going to be where we profile and cut all the way through. 0.759. Let's increase that to 0.6. 0.759 plus 0.025, 0.784. Now, it'll give us a warning because our material setup over here is told 0.784, so it updated it. So I measured it, and I don't want to do that. I want this to be 759. Okay. Then I want to select that first vector, profile, 784. So we're increasing it 10 thousandths. All right, 784. Now select. So yeah, let's add a tool. It'll be tool 8. Single, it's going to be a 2 flute up cut spiral, end mill, and let's edit that to 3/4, 2 flutes, pass depth, sure, 3/8, step over 40%. We'll leave that. And we'll see if the OnsRoot catalog gives us a guide in terms of chip size. Recommended chip load per tooth. Yeah, this is good. I mean, it wants 0.006 to 0.008. Except, no, they want a larger chip when you go to 3/4 diameter. So the table is telling me 11 to 13 thousandths. Right in the middle in terms of chip load, 12 thousandths. Moving inches per second, feed, plunge, tool number. This is tool number 8. Apply. Select. Edit passes. I did like having the multiple passes. It allowed me to, and I'm going to experiment with this. I'm going to leave it at multiple passes again, just because I want to have a lot of time to turn the machine off if I don't like how the material's being held down. Okay. So now we want to be on the outside or right of the line. That's accurate. We certainly want that over here. We don't need any tabs, not at all. Don't need a last pass. We are going to ramp. Though, it's an end mill. We don't have to, but it's not a drill bit, so we'll ramp in. And this is going to be called profile. Outside. perimeter. Calculate. Yeah, we knew that. We're going to get through there. Okay. Yeah, we know we're going to go through. Um, okay, so that's, wait a minute. Yeah, we want to climb cut that. The edge looked really good on what we made, so we'll continue climb cutting. And in the Onsrud catalog is where I found the recommended chip load per tooth. Yeah. So now, luckily, we have that same chart up because now we're going to switch these to the profile. Uh, yeah, and on each of these will be to the left of the line. And each of these three will be to the left of the line. All right, let's tool path this. Now, this is the one, oh, you know what we have to do is we have to experiment with that. Um, actually, let's do that. Let's save version 2 because what I want to experiment with is the pocketing and setting this up. So let's actually experiment.
If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video.
All right, so let's talk about how we're going to experiment with this. Right now, we basically have our panel that we cut out. And what I'm going to do is just move the tool to a safe position where we can actually look at what we're dealing with here. Here's what was left of our cut. So basically, this is an extra spoil board, so we're going to experiment right into this. And we'll probably just experiment with like a pocket tool, like a circle tool path. So, you know, if we're playing around like at 1 foot and 1 foot, we'll have no trouble at all. Just what we're going to do. That's not what we wanted. That is not what we wanted. All right, so we're going to change our material setup for this test to 24 by 24, and we'll leave the thickness. It doesn't matter because we're just going to be making a pocket. So let's toss a guideline at 12 inch, and then one down here at 12 inch, and this will be our little center area where we're going to work from. So what's going on with this? Material setup. Actually, we'll go right in the center. That'll be our datum. That's perfect, actually. Okie doke. Let's create a vector. Let's do a circle. Let's make it 3-inch diameter. Okay, awesome. Got a vector selected. Let's pull up our tool. Pin that pocket. Let's say a start depth is 0. Now let's make a cut depth of 0.125, eighth of an inch. Awesome. Our end mill is still in there. We'll climb cut. Doesn't matter. Ramp, the whole 9 yards. Pocket 1, calculate. We're raster cutting, so let's get out of that. It's pocket let's offset. Let's just call it pocket 1. Hopefully it overwrites it. It doesn't. Get rid of this. Let's preview the toolpath. That looks fun. Okay, let's close. Let's select a toolpath. Let's save the toolpath. Let's just call it home. Test pocket 1. Save. It'll be good. Now let's go. Let's just go MH. Then M2. I'm sorry. MZ2. Oh, aha. No bueno. M2 8, 8. Enter. We didn't zero it off of that new surface. C2. Let's zero it. Now we're zeroed. Now we're going to MH. And now we can load the file. Test pocket. We're of course going to 3D offset that first. And let's just cut it. That is not what we wanted. Now, what happens? So we didn't move ourselves to 1212. So we're going to need to quit this. We're going to need to home. So we started to run that 3-inch diameter circle from 0, 0. And that needs to run from 1212. Okay, now we've done that. Let's M2 12, 12. I believe that's positioned. Okay. That's where it is in our 24 by 24 inch piece. Now let's air cut. Let's see what happens. Okay, so we've got the tool moved to a safe Z height. That appeared to work just swell. Now the next video you're going to see is going to be actually cutting it. Let's do that. Okay, so we've got the tool moved to a safe Z height. And now we're air cutting. And it certainly looks correct.
enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
All right, we're going to get our GoPro set up. We're going to turn the vacuum on to make sure that the valve is open. That's not what we wanted.